property. I will split the discussion on these properties, okay, into two videos. For the first video is just a simple function, and the second one would be a more complicated function. Okay, before we proceed, let us discuss some important points. First, you know that Laplace ft, or given function in time domain, when we try to transform by using the Laplace transform, by taking the Laplace transform of the time domain, you will get an equivalent function in frequency domain, which is fs. Let's say your function is gt. Okay, you take the Laplace transform of gt. Your equivalent function in s domain would be g of s. Okay, the function will follow what is your function in t. Okay, the function in s will follow what is the name of your function in t. Okay, so that is a simple definition. When we go to the Laplace inverse, we take the Laplace inverse at both sides of the function, we will get Laplace inverse Laplace gone. Then we can conclude that from this function, we have Laplace inverse of fs is ft, which means that if you are given a function in s domain, in frequency domain, you need to take the Laplace inverse of that function, and then you will get the equivalent function in time domain. Okay, understand? Okay, so next we proceed to the property of Laplace transform, which is the first shift property. You are given ft, and dft is multiplied by eat. Okay, eat ft. Then the solution is no more fs, but the solution is fs minus a, which means that firstly, you need to find out what is fs first. Okay, then your solution is fs minus a. Whenever you find s, you must replace s by s minus a. How to get fs? Go back to the definition here. In order to get fs, I must take the Laplace, this one in order to get fs, I must take the Laplace transform of ft. So here, this is your ft. You hold first your eat, you hold first this one, you hold this one. Okay, you close first this one. Okay, then you take the Laplace transform of ft, then you get fs. Okay, you get fs only. Okay, but that is not your question. Your question is EAT. Then only you open back your EAT. You open back your EAT here. Then take your Fs. Replace Fs by Fs minus A. Whatever solution that you have in your Fs, whenever you find S, you must replace Fs by Fs minus A. Where you take the S, where you take the A. A comes from your here EAT. EAT. Okay? So that is the first shift property for Laplace transform. But now we want to discuss the property of first shift property of Laplace inverse of Laplace. So let me copy this one. Laplace EAT ft. Okay, this is what we have discussed previously in Laplace transform. Okay, but now inverse of Laplace transform. So I try to take the Laplace inverse at both sides of the function. Okay, that is the idea. Laplace inverse, Laplace. So gone. So what you have? EAT ft on your left. On your right, you have Laplace inverse of fs minus a. Okay, I try to modify a little bit on this function, on this definition, so that I have Laplace inverse of fs minus a, okay, is EAT ft. EAT is EAT, but my ft here, I can refer back to the basic definition, which is this one. So EAT is Laplace inverse of fs. This is very important because you need to understand very well the definition. Okay, You just play around with the definition. Okay, so I can conclude that from this definition, I can conclude that I have Fs initially, but this S is replaced by S minus A, means that each time I have S, this S is replaced by A. So that is why I have Fs minus A. Now, I want to take the Laplace inverse of Fs minus A. What I need to do is, I need to take out EAT first. You just write down EAT. EAT, so A, this A comes from your S minus A. You just put your EAT. Then, after you take out EAT, you need to erase all your A. Then take the Laplace inverse of the remainder, which is your Fs, because Fs minus A here, minus A, is already taken out here. So that is why A is gone. So what's left? Only Fs. So maybe you find difficult to understand the definition. So let us try to discuss a simple function first. Okay, so solve for this one. Okay, 2 over s minus 3. Okay, take the Laplace inverse of 2 over s minus 3. Without looking at the table, we try to solve by using the property. Okay. Okay, so 2 is 2. Laplace inverse. I just take out 2, okay, from taking the Laplace inverse. Okay, so the remainder is 1 over s minus 3. Okay. From this definition, I can read this function as A. Actually, this function is 1 over s tau. But this 1 over s is replaced by 1 over s minus A. Okay, so that is how you read the function tau. Okay, so what you can say about your A? Okay, this s is replaced by s minus A. So what is your A? So A is 3. So you write 2, what the function said here. Okay, the definition said that you need to take out EAT. So A is 3. So you have E3T. What I said just now, when you take out A, so that you need to erase your A at your S minus A. So I just erase this one because I already take out 3. Okay, I already take out my A. So what's left? The function left is 1 over S. So it is match our definition here. Laplace inverse of Fs minus A, okay, equals to EAT Laplace inverse of Fs. Okay, so you have EAT. Okay, Laplace inverse of no more Laplace inverse of Fs minus A. You just have Fs only. So I have 2E3T Laplace inverse of 1 over s, then only I refer the table. 1 over s is this one. Your A over s. Your A is 1, so you just have 1 here. So the solution is 2E3T. If you don't confident, again, you try to take the Laplace transform of this one. Because this one is t, right? In t, time domain, you need to take the Laplace transform of this one. You must be able to get the question back. Okay? Alright, so that is how we apply the first shift property without looking at the table of Laplace transform first. Okay, we move to the second one, this one. Take the Laplace transform of 1 over 4s minus 3. Okay, this one. For this kind of question, you need to do a little modification. Okay, so what you need to do is, this is actually s, and this s is replaced by s minus a. But in front of your s, you have a constant, a coefficient. Okay, so what you need to do is you need to factorize the function first. Okay, so I have 1 for s minus, we cannot put 3, but we need to put 3 over 4 because 4 here and 4 here and this 4 can be cancelled out so that you have the original function back. Okay, so I know that this one is 1 over 4. I take 1 over 4 out from my Laplace inverse, so I have this one, 1 over s minus 3 over 4. Okay, by using the definition just now, 1 over 4 is 1 over 4. Laplace inverse of 1 over s minus a. S minus a. So I can conclude that my a is 3 over 4. So I just take out EAT. Then I erase my a. The remainder is Laplace inverse of 1 over s. 1 over s, Laplace inverse of 1 over s is 1. So I just have EA. Simple, right? Okay. Let's say we have this one. Okay, I continue here, okay? Laplace inverse of 10. You have 10. I just take out 10. Okay, 1 over s plus 2 to the power of 4. Okay, 10 is 10. I got a little bit flu sikit lah. Sorry So Laplace inverse of, okay, let us read this function. What can you say about this function? Okay, this is actually 1 over s to the 4 tau, madam. So you need to read the function like this. This is actually 1 over s to the power of 4. But this s is replaced by a. Okay, this function is replaced by s minus a. Means that we have EAT. Go back to the previous lecture. Okay, we must have EAT here. Okay, because the existence of EAT makes this function as becomes s minus a. Okay, when I say that this one is 1 over s minus a, we can conclude that you have a equals to negative 2. So EAT s minus a, s minus minus 2, then only you get plus 2. So that is why a is negative 2. So I just take out e negative 2t first. Then I erase my a because we already taken out our a. So what's left? We have 1 over s to the 4. Okay. So 10 is 10, e negative 2t. Okay, then only we find the table, we check the table. Alright, we have Laplace inverse of 1 over s to the power of greater than 1. Okay, so that is one. Okay, so Laplace inverse of 1, you have 1. S to the power of 4 is s3 plus 1. Okay, so I write the solution 10 e negative 2t. 1 over s to the power of 4. I must expect that my solution is this one. T to the n. What is n just now? N is 3. So t cubed. That is our solution. You must expect that this is our solution. Okay, so t cubed. But in order to get t cubed, as the solution, we must have 3 factorial here. Okay, but this 3 factorial does not exist. You create the 3 factorial so that you need to divide your function by 3 factorial back here. 3 factorial is 3 times 2 times 1, which is 6. 6. Okay, so you have divide by 2, so you have 5 over 3 e negative 2t t cubed. Okay, so that is how you use the table and apply the properties. If you still feel not confident, so what you need to do is take the Laplace transform of 5 over 3 e negative 2t t cubed and apply the first shift property of Laplace transform. Okay, Laplace transform, the previous lecture. Okay, this one you apply the first shift property of Laplace inverse when you get the solution in time domain. So you need to apply back here the first shift property of Laplace transform lah. Understand? Okay. Alright. This one. Maybe this one is the last one. The last example. Let's say I have to take the Laplace inverse of, you have 5, negative 5, okay? Negative 5 Laplace inverse of 1 over s plus 3 square plus 9. Okay. Just the same thing. So I have negative 5 is negative 5. I take the Laplace inverse of a. We have s minus a lah here. Okay. So s minus a. What is your a? A. S minus a. You have s plus 3. It means that your a is negative 3. Okay, so you have EAT, negative 3T lah. Okay, so that we need to erase our A. So what's left? Only 1, sorry, Laplace inverse of 1 over S square plus 9. Okay, by now you should be able to guess your solution. Okay, you have S square plus 9. We might have either cos 80 or sin 80, but here you have a constant only, so that you must get the solution of sin 80. Good. Sin 80. What is your A? A. This one is your A square, so that your A is 3t. But remember, in order to get the solution sin 3t, go back here. Sin 3t. Okay, sin 3t. Okay, look. Your 9 is a square. Therefore, your a, your solution here is sin 3t. Okay. But remember that your numerator must be a, which is 3. But you don't have 3. Here, you have 1. You must make this equation as 3. So then only you get the solution sin 3t. You create the 3, but this 3 does not exist. You create the 3. Okay, you multiply the function by 3. You need to divide it by 3. Okay, this one. So the solution is negative 5 over 3 e negative 3t sine 3t. Okay. You can take the Laplace transform of this function by using the first shift property. Then you will get the question back. You will get back the question. Okay. So I think that is enough for the simple function. After this, I want to discuss a more complicated function. Okay. Not really complicated, but the other macam ni cakap the other form of first shift property in Laplace inverse. Okay.